Hello, 7th grade, and welcome to Chapter 13 of your Becca textbook, Ecology, Harmony, and God's Creation. This is the last chapter in your textbook that tells you just how far we've come in learning life science. You are almost done, so keep your eye on the prize, and hopefully that prize for you will be 8th grade. If you pass, of course, which I'm hoping you do, because due to the coronavirus, I'm not sure we can do summer school. So I guess we're going to find out. Let's begin with 13.1, Introduction to Ecology. Now, just because it's not a blank in the notes does not mean it isn't important. There are things that you probably want to write down beside your notes, especially in this chapter. And there's a little bit of reasoning that goes into this chapter, and that's the main reason why. So let's take a look at 13.1. What is ecology? Ecology is the study of how living things interact with one another, and of course their environment. Now, every living thing has what's called a niche. And some people pronounce this niche. I like niche better. A niche is a role or a spot or a place an organism plays in its environment. Consider these three warblers. And you can see this in the picture here, how they're all warblers. I mean, you'd expect them to all do the same thing and play the same role, but they don't. You see, even in this spruce tree, there are different spots that these warblers have. Some feed at the very top, some in the middle, some at the bottom, and they will eat different things. They will do different things to the tree, and they will come in contact with different organisms just simply because of their location on a spruce tree. And the spot or role that an organism has in its environment, it's pretty protective of. I mean, they don't like to give up their spot on the tree. That's where they like to be. And fortunately, our spot in the ecosystem is typically at the very top of the ecosystem. We are what is called an apex predator. We're at the very top of the ecosystem. And we also interact with other living things. Now let's consider this picture. We have a deer. That's the most obvious thing. And in order to study this picture, we have to think about biotic and abiotic factors. An abiotic factor is a factor that's not living. A biotic factor is one that is living. So let's consider this picture. We'll start with biotic. What are the living components of this ecosystem? Well, obviously you'd look at that picture and be like, a deer? But I figure that there's a whole lot more going on that's alive in this picture than just the deer. How about the grasses down here? Or the moss, the tree? How about all the minnows that are swimming around in the water, or the bacterium or algae that you can see floating around the top of the water? I mean, those things are alive, right? So there's a lot of biotic factors in this picture, and there's a lot of abiotic or non-living factors in this picture. You see some rocks. Those certainly aren't alive. The water isn't alive either. The dirt, right? All this dirt. Dirt's not alive. Even some of the things such as the air, the sunlight, can be considered an abiotic factor because they do affect an ecosystem. An ecosystem is definitely affected by the amount of air it has. And there's a lot of things we can pick out, even in just a simple picture, as far as biotic and abiotic, life and non-life. Here's another thing to think about. So, things have a range, right? We have a range of how we like things. So, you go to a restaurant and you order a steak, right? And you can order it rare, like medium or well done or like burnt, right? You can have a range of ways you can eat your steak. Same thing in all of life. There's a range. And there's an optimum range, what we like the most, And then there's like a stressed range, also called the tolerance range, where you can survive, you just don't like it. And then there's a lethal range, where you're dead. Now, let me pull out my pen here. What is the optimum range? Let's take something like temperature, because that's a range, right? What temperatures do we like and are optimal for human beings? I'm going to say 70 degrees to maybe 80 degrees is perfect for human beings. We don't really, we're not shivering, we're not too hot. It is ideal for us. Well, the stressed range. We can survive past 80 degrees. What do you think we can survive up to? I'm going to say we can probably survive on the regular basis constant temperatures of probably 95 degrees. Now, that would be terrible. We would be so hot, it would be disgusting. We'd be sweating all the time. But our bodies would survive. It's a tolerance range, not an optimum range. Tolerance. And I don't know about you, but I am one who gets very cold very easily. And we can survive below 70 degrees. We can probably survive all the way down to maybe, 55 degrees? Without any, blankets or anything. We'd be really cold. But our bodies would live. Now, above that or below that, we would need some help. We'd either need air conditioning or heat in any form. Because our bodies are not meant for anything outside of these huge ranges. And fortunately, we do have the ability to heat our houses or to use air conditioning so we don't die when the weather gets into those ranges, or else we die every summer here in Florida, right? And the goal for an organism is to hit this optimum range. There's ranges for everything. There's a range for the pH in your body. Your body likes its blood at a toasty 7.4 pH. Goes too high, you die. Goes too low, you also die. There's even a body temperature range. Right, you can survive 102 fever, right? It's not optimum, but you can survive it. You can tolerate it. Can you survive 106? No, not usually. A limiting factor. A limiting factor is anything that holds a population back. Now, a limiting factor can be categorized as a density dependent or density independent. Density dependent depends on the density. Density independent does not depend on the density. So, density is how close organisms are to each other. So, if it depends on the density, it's something probably like disease. Disease is density dependent. You see with this coronavirus, the state that has it the worst is New York. Why? Because they're really high density. What's the state that has it the least? Probably a state like Montana or North Dakota, a state where there's not a lot of people. So they don't come in contact with one another to share the disease. That is density dependent. It depends on how many people are there. What's density independent? Something that doesn't depend on the population size. Consider like a hurricane or a tornado. If a tornado tears through a trailer park and kills everyone in that trailer park, it doesn't matter how many individuals are there. The tornado's size is going to be the same. The tornado is going to blow through that trailer park whether there's 5 people in there or 1,000. And it's not going to change anything. Or like a hurricane. A hurricane can hit, the eye of the storm can hit a small town in Florida as well as a town like Miami. It doesn't matter. It's going to hit both towns just as hard. Here's a couple more essential terms. I gotta hurry because I can only record for 15 minutes. Essential terms like carrying capacity. A carrying capacity is the max amount of individuals a population or an ecosystem can support. So here's a population of something, just something random, and the carrying capacity is the amount the population can hold. You can see as soon as it starts to go over the carrying capacity, things start to die. Why? Because when overpopulation hits, things run out of food, run out of space to live, and an overpopulation is not a good thing. Biodiversity is the number of organisms and the variety of organisms in any given area. And a biogeochemical cycle recycles minerals and nutrients into the environment, so it keeps it going. Consider like the water cycle. So evaporation, condensation, precipitation happens in a circle, and it keeps our water supply moving. There's lots of biogeochemical cycles, even the nitrogen cycle, the carbon cycle, lots of them. And that leads us to an idea, it's called succession. So let's say there is a volcanic eruption underneath the ocean, and it forms a new island like Hawaii. The first things that are going to get to that bare rock is going to be like lichens and mosses. You're not going to suddenly have a maple tree, just bam, it's on that rock, right? Because there's no soil. So you need things that break down the rock, like lichens and mosses, to start. And then maybe some herbs and weeds can grow, and then grasses, and then we have some bigger trees. And that's primary succession, somewhere that's never been inhabited. Secondary succession is an area that has been inhabited. It has soil, and it has a pre-existing community, but it got destroyed. So think maybe a forest that caught on fire and everything died, but there's still soil there. So you can have plants grow right away, and then eventually the trees do come back after time goes on. And this is all for section 13.1. You do have some homework. 13.1, numbers 1 through 5, and thought question number 1. Please get that done. Hopefully you're watching this video sometime. I believe the lesson plan said on Thursday. So you will tune in tomorrow on Friday for 13.2, which I'm excited to talk about. I will see you guys later. Stay safe and enjoy your time with your family. Alright, bye-bye.